My name is Tim Rinaldi, Discipline Chief for Design on the FRC Team 4557. I was initially introduced to FIRST Robotics in middle school when my dad took me to an FRC event in Waterbury, where I met Team 4557, the Full Metal Falcons, in the pits. That day was a big reason why I eventually decided to attend Xavier High School in Middletown. During the first 3 years, I had a unique opportunity to participate and contribute to an incredible team in the following ways: advancing our prototyping skills, introducing CAD and some CNC machining, turbocharging our 3D printing capability, being on Drive Team multiple times, going to Worlds in 2018, re-imaging our pit design, contributing to winning Engineering Inspiration and Chairman's Awards, and helping dramatically expand our outreach into the community. I am now the Senior Lead Engineer for Design on FRC Team 4557. Much of our team has graduated last year, but now equipped with design skills in prototyping, CAD, and 3D printing. This is how we roll. It all starts with kickoff when the entire team of mentors, students, and some alumni get together to discuss the game, strategies, and possible designs. The number one challenge in this year's competition and the obstacle we faced were the yellow balls. They are grippy, squishy, and very unpredictable. Handling and moving them is not easy and often results in bind and grip on anything they touch. This year we focused on handling and transporting these balls. We needed to intake, transport, and shoot these all while staying within frame dimensions. Because this is our focus, we needed to hold as many balls as we could, up to 5. We also needed it to be spacious for them not to bind. We call this component the torpedo. The next step was to bring this concept to life using 3D CAD to space plan the component into the robot. Projecting the CAD enabled the entire design and build team to critique multiple designs and finally go forward with the best plan. Because of our systematic need, we decided our torpedo had to be adjustable in every way possible. We reached out to a couple of companies and teams and discovered 8020, a professional-grade aluminum bar stock with 100 of hardware types to create a quick setup that's easily adjustable. After integrating it into the CAD, we immediately started prototyping with it and created an adjustable design for the transport system. This is the first time we've ever used 8020, and we are very happy it works so well. Because of the sphere shape, we wanted to create a way to transport the balls in a linear fashion without squishing or binding them. I came up with an idea of an hourglass spindle to shape the guides and allow for not binding, all while holding the stress of the polycords. I CAD'd a unique hourglass shape to hold the polycords and guide the ball with equal compression while keeping it centered in the torpedo. I sent it to our safety officer who owns a resin printer and he printed it. We decided to use resin and not the standard layered PLA for performance and durability. With these spindles, the ball wouldn't get trapped and squished into the frame and easily pass through the chamber. Now that the transport was looking good, we needed a way to get the ball from the ground into our frame. We started with pistons and rollers to suck it in and position it for the transport. We initially printed and tested variations of mechanism wheels that we noticed really had no effect on centering the ball and not enough grip as we thought they would. In this case, being able to CAD and print, even though we didn't end up using them, saved us over $100 in time testing them. This showed us rubber small wheels was the better design for speed and durability. The last added idea was the shooter to speed up the balls at the exit of the torpedo. This we created easily with quick mount Neo motors never used before by us, which worked perfectly only because we could easily mount them to the torpedo. Initially, we knew the wheels had to be perfectly placed, so having adjustability and a bridge port was perfect. We tested the shooter and surprisingly, it was accurate. Testing at our school looked promising, and after we fine-tuned it and tightened it up, we took it onto the big field. The robot performed better than expected. We were pleasantly surprised that the torpedo, with so many adjustable components, needed very little tweaking during competition. It did exactly what we designed it to do: intake, transport, deliver to the low goal, as well as shoot in the high goal. Things went so well we ended up becoming number 3 Alliance captains, raising the team spirit in a perfect way, and creating a perfect reward for such a tremendous team effort.